Hello, good afternoon. Hello, good afternoon.
Sir. Good afternoon, sir.
How are you? Tinoye, everybody.
Yes, sir. I think
Sorry,
so.
I'm just coming in from church. Sorry for keeping you waiting. Yeah. Um. Thanks for the opportunity to come and rub minds with great people in LBS Analytics Club. So I'll try as much as possible to do as much as we can today. So let me log in on my workstation. Can I ask a general question about last class? The plotting and the exploratory data analysis of Python so far. How do we see it? How has it been? It's a question.
Okay, it has been a wonderful experience. We are really learning.
You are here learning?
I say I'm really learning.
Okay.
Thank you so much.
How have you really found it? How applicable is it to issues, real life issues, your day-to-day work, and in general?
Okay, so for somebody like me, I just joined the club. So I'm not really learned much. I'm just trying to keep pace with the trend of learning. So I started with Python. So I'm still trying to understand the concept of Python, but I'm not yet there.
Okay. But you are conversant with Excel before now?
Yes.
Okay. All right. So this is your first encounter with Python?
Yes.
That's interesting. That is what they call baptism by fire. Okay, yeah. I would just like to share that you need to put in extra effort to learn, really. Consciously put in extra effort to learn more, especially than what you are being taught in class. I can say specifically that Python is very volatile. I don't know if you get my word, what I say. Volatile in the sense that it evaporates easily. You use it to solve a problem, you use it to do it now, and the next minute you forget. You try to replicate it, and you to be as if you never learned this particular. But one thing that could work for you is if you use it regularly. Try to find problems, try to test each time what you have done, redo it again and again. Learn over and over from different sources, and that is just one of the things I think be of help. Fortunately, my system is taking time to come up, but I'll try to use this one to engage us. Sorry, I just came back from church and yeah. What should I do? Can I restart? Restart, no, I have to restart a lot of things. I have to restart a lot of things. So that's that about that. Then I also will see that Dr. Francis is trying to take us from the known to the unknown, trying to relate most of the things we are doing in Excel to how we can achieve the same thing in Python. But what I'll just chip in is that one issue that we have with Excel is the limit to the size of data it can handle per time. One. Two is that when you are using Excel, Excel brings the data into the application. The data you want to work on, it brings it into the application, and that tells on the performance of the application. I could say that I had a challenge sometime when I was using some up to like how many thousands, just some few hundreds of thousands of rows of data, and my system kept on crashing until I was able to work on that data without loading it into the system. So Python is one of those tools, just like SQL. SQL can, you have your data stored in a particular repository or database, and SQL will pick the relevant ones. Maybe you just want one row, you want one column, or you want to select a particular feature. Maybe some things that are, you have data for the whole of Nigeria, you want data that relates to maybe only Lagos State and Abuja, and you can pick up those things and use the data you want without loading the entire file into the system, thereby slowing down the system and exhausting the memory of the system. So today we are supposed to be looking at machine learning, and it is a build-up on what we have been learning on Python so far. Permit me to still be discussing with us like this while I'm trying to put my system in place. I should have logged on maybe like some minutes earlier than now. This is what it is. Okay, so from what I will just try, I think I have some things in my head of what we are talking about. So we are talking about machine learning. And what does machine learning mean to us? I would like us to be interactive. I know Dr. Francis does most of the talking. I'm a student like us too, some years back. So please, I would like your support to encourage me. Machine learning is not a topic you should be giving to a student like me. So, Tinoye, are you there?
I'm here, sir.
Yes, ma'am. So I'm taking the bull by the horn. So please, I would like us to work together. I need your encouragement by responding to you. So talking about machine learning. That is what we are talking about today. And what is machine learning? What do we understand by it? Or can somebody just give a guess? At least maybe somebody would have had an idea of what machine learning is about, please. So we'll be able to know if we are all together, if we're on the same page. And then attempt, please.
Okay, can I try?
Please do. I appreciate.
Okay, so my basic understanding of machine learning is that it's used in predictive analysis. And there are different methods that is used in machine learning. I know one relies, I can't remember what it's called, relies on trying to understand patterns in previous well, I say previous behaviors or previous results and try to use that to predict whatever results you're trying to predict. Or generally it's used in predictive analysis.
Predicting analysis. Predicting analysis. No, not predicting analysis. I appreciate the word predicts, which is similar to forecast. And it is actually talking about being able to, once you feed the system with a particular set of data, it will try to establish a pattern or trend. And from that trend, the system will be able to use that one to generate a likely outcome for a possible a given scenario. And I will take us back to, okay, thank you for that very bold attempt. I appreciate that. And I appreciate that it doesn't have to do with machine per se. Doesn't have to do, it's not like some robots just have to do. At our level, machine learning is just using data, asking the system to be able to learn from previous experience. And how does it get previous experience? Data. And that data is what it's going to use to be able to reason or build its intelligence on for handling future occurrence of similar scenarios. And for this machine learning, a lot has to do with mathematics and statistics. Today, I will do something. I would like to set records straight for how we use for machine learning. I would like us to get some understanding and get some things right. I wish I could have something to write with, but notwithstanding, I will do my best to give as much illustration as I can. Before we start talking about all the terminologies or trying to go to Python and start crunching the codes. The reason is when I started with Python, when I got to machine learning, I got lost because those terminologies are just enormous, too much for me to understand. So I would like us to clarify all these terminologies. So when you come across them at any time, it will be like, yes, we have described this thing before, we have mentioned this thing before, and it won't be strange. So we'll just be applying it into Python directly. So now my system is I just restarted. I had to add a restart. So it's just coming up. So it may take some time for me to share my screen. I did a kind of list of things that I feel we need to know. Whenever I want to learn something, I try to get to know the content. What are the things I really need to know? And I did this kind of table of content. I was able to create one. And I'm like, yes, if we can understand these basic things. In fact, there are some things we could have omitted. If we can understand these things, then we'll be able to get it right. I will start from the known. And that is, machine learning is actually the use of an existing data, learning from it, establishing trends and patterns to be able to use it to predict a future outcome given a scenario similar to what we have had before. Even if it's not similar, the system will be able to either extrapolate or interpolate and get the exact, make the a decision that is necessary. Now, in machine learning, there are 3 or 4 categories, broad categories of machine learning. This one they call supervised machine learning. There is one they call unsupervised machine learning, then reinforcement learning, and it used to be 3, but recently they came about one which they call generative AI. That generative AI, that one has to do with it's an advanced part of machine learning. They call it, is it neural networks or deep learning or something? That is for language, neural networks and the likes. Now, back to supervised learning. I would like to take us from something we all know before now. That is something they call equation of a straight line. We know it. Y is equal to ax plus b, or y is equal to mx plus c, or y is equal to alpha plus bx, depending on however you want to describe it. That is the simplest form of machine learning. I don't know, I hope we are following. I hope I've not left out anybody, because I want us to get it right. There are a lot of terminologies. For example, when it gets to a level, somebody will start telling you about algorithms for machine learning. And when you get there, you might likely lose it completely. But I don't want us to jump to that one. I want us to get this part right. So, talking about supervised, and a simple example of supervised learning is the equation of a straight line I just mentioned. They call it linear regression, where you have a plot diagram and you draw a line of best fit. You get the point? You draw the line of best fit and you try to now use that as the likely path, or the best way to describe that data set. So in this case, you have, if somebody gives you a scenario, okay, let me come this way. If you are given a simple data set, let us just follow as I'm saying it, that for you to get A grade, you need to be reading at least 10 hours a week. For you to get a B grade, you need to be reading at least, let's say 5 hours a week. For you to get C grade, you need to read at least let's say 2 hours a week. And for you to get, of course, D is like fail. So anything below C, that means you are not able to read up to 2 hours. So from there, you can say this guy reads 8 hours a day. From your prediction, remember we said for you to get A grade, you need 10 hours a week. For you to get B, you need 5 hours a week, personal study. And C, you need at least 2 hours a week, just for you to scale through with C. So anything below 2 hours a week, you will likely fall into grade D. So if somebody say, I've been reading 6-7 hours a week. What grade will you say that person should get? What grade will you predict that that person, this guy is likely going to fall into what grade category? Hello?
Yeah,
Yes.
is it B?
B.
Is it B?
Yes, you are right. Definitely it is B. Because if you plot the chart, 10 hours, greater than 10 hours is A. Between 10 and 5, let's say that is B. So that is how predictive learning works, linear regression works. And that is how the system, but you don't need to draw the line. You don't need to give the system the equation. Once you give a kind of, maybe you do a survey, you give the system all the, sorry, I'm trying to look for the link for LPS so I can connect. So once you give the system this parameter, once you give the system the set of data, a survey, like you see, this person says, I have so grade, I have so grade, or you have the data, and the person says, I read 10 hours, 15 hours, I read 6 hours, and the system will be able to automatically generate that trend. The system will be able to know that for you to get a grade, at least on the average, you need to reach at least 10 hours. That is that condition. Now, another thing is that the way the equation works, regression, you can have a survey that has more than one independent variable, not only about how this person reads. You can also factor in the age of the person. If this person is a Gen Z, he can afford to scale through with just 5 hours a week, and he will still be in that category. If the person is an old person coming to do MBA at age 60 or at age 50, his brain may not be able to absorb things like the way the brain of some of us will. So you factor in that parameter. Set another parameter you can factor in is if you say a male or a female, you can say women, they have issue family responsibility, taking care of their children, and so especially at a certain age, maybe between age 25 and maybe age 35, they are very busy and engrossed in family. So the number, they may not be able to have that number of hours, but somehow they are still able to get a grade. You put that factor in, gender, age, remember, the number of hours you put in, remember? Then you might also look at the background of this person. Which school did this person finish from? And that is how the system will be able to factor in all these things and be able to generate a kind of, they call it how do you call it? It's a kind of linear regression. It's still line, but it's not a single parameter. It's not a single independent variable, multiple independent variables. So the system will be able to factor in, and that is where you have, is it multiple linear regression? You have y is equal to ax1 plus bx2, where x is the independent variable, cx3, dx4, on and on and on like that until you get to nxn. I don't know if you are getting what I'm saying. Let me check something, please. I'm sorry, please. Yes. So just like that, we are talking about regression. That is the simplest way we can describe machine learning. So supervised simply means that you are able to give the system the data, and it will now categorize it according to labels that you have given it. This is Y, this is independent variable A, this is independent variable B, independent variable C. You have labeled everything. The system will now use that one to learn. They call it training. After you train, you test. After you test, then you adopt that as a model. Not only that, you evaluate those things you have done. You check if it is okay, because there are different ways of generating the algorithm. And the way Python works and how it helps is that you don't need to go and be the one generating your own pattern or your own formula. There are some models that have already been, or libraries that have already been created ahead. And with these libraries, I think my system is up now, so you can see my face. Okay, good. Okay. Hello? Hello? Are we good now?
I can hear you.
Okay,
We can hear you.
good. Yeah, good. Thank you very much. Thank you. Thank you for the patience. I'm trying to, I even created a PowerPoint. Let me bring it up. So we'll be on the same page. And I'll open my Anaconda. I even try to, how many of us have used Google Colab?
What?
Google Colab. Google Colab.
No.
Google Colab, VS Code, Atom, Sublime.
VS Code, yes.
Okay, good. So there are still some schools of thoughts. I try to see if I could test all those stuffs, all those IDEs, but unfortunately, I don't have the luxury of the time to be able to say I have tested every one of them. I tried VS Code, I tried Google Colab, I tried Jupyter, I even tried Spider recently under Anaconda, but I can't see which one. All I know is that since I see some of them are better off for some things than the others. So that is what I can say. But so far, so good. I'm going to stick with Anaconda and Google Colab. Yeah, at least for today, I think every one of us is on Anaconda. So that is what I would like us to play with. So back to the discussion I was, the way I was describing this thing, I was trying to describe multiple linear regression and single linear independent and one independent linear regression, which is actually under supervised learning. Then going forward onto the unsupervised, I'm bringing this in from my head, unsupervised linear, unsupervised machine learning. That's one. It won't give you how am I trying to describe it? Also, after unsupervised, unsupervised, there's another one they call it semi-supervised. There is actually a thin line of demarcation between those things. Now, unsupervised does not necessarily require drawing a graph. It has to do with things like grouping data. It's the header that this is your X, this is your Y, or this is your X1, this is your X2. No, the system will be the one to be able to distinguish using all the parameters and be able to come up with the grouping. They call it, is it clustering? They call it clustering. So another form of unsupervised, is it supervised or semi-supervised? I don't know how to put it, is classification. Okay, yes, let me put it. Classification is under supervised. Linear regression is under supervised. Then clustering is under unsupervised. Now, when I say classification simply means that we have the same data set I referred to earlier. As in, if you read up to 10 hours, you will get a grade. If you read below 10 hours, between 5 and 10, you get B grade. If you read between 2 and 5, you get C grade. Now, how does classification come in? Classification is either between two parameters, either pass or fail. It won't give you option of A, B, C, D. No. It will give you either pass or fail. So when you have those two options, all the system does is this one passes, this one fails. And that is how it is being deployed in a lot of things in real life situation. When I say real life situation, I'm referring to things like you have circuits. The system knows when to, okay, you have things like I'm thinking of a good example of classification, but I've given you one, pass or fail, really. The system will be able to say this one is passed, this one is qualified, this one will be able to do well in this course, in this field or not. It's just a simple yes or no, true or false, okay or not okay. That is what it does. Now, going into applications of machine learning and why machine learning comes to be. I know that Dr. Francis mentioned they tried to differentiate between AI, ML, and data science and some things last time. So I don't think to go into that, except if you have if anybody desires that. But going into the issue of, I don't know if anybody wants to take me back, if there's something you want to take me back on, or if you want me to focus on a particular area so I won't be taking you around. I know I'm dealing with people whose time are very busy and who may want. Are we together?
Yeah.
Any focus area, something, so I'll be able to go in the direction you want? Or we should just continue this way?
So far, so good.
Okay. I'm trying to carry those people coming from new people to Python. I'm trying to carry them along. I don't want to bore our seniors as well at the same time.
Please
Yes,
keep
sir. So
carrying us along. We appreciate. Thanks.
Okay, yeah. So in essence, machine learning means that you don't need to write equations. You don't need to be a software developer. Once you create a model, feed it with a data set that this is how this thing behaves, then the system will be able to adopt that model and use it to predict for the future. There used to be a time when Google Map does not recognize things like one way. You understand? It knows that there is a way between this place and where this person is going. But if you are not conversant, you will just enter it and you will know that it is a one way. Similarly, there is a new rule, something I read in the news recently, that Google Map may land some people in trouble in the UK because they are changing the speed limit on some areas. And Google Map actually factors that speed limit in calculating the distance or the time it will take to get to your destination. So if you are not careful and you are not conscious, and this system does not tell you that this limit place is so, you are not supposed to exceed so speed, and you enter into it, you might actually, so it is learning. Over time, they will change the algorithm, they will update it, they will do some other tests, and it will now be getting, it will get improved over time. There was a time I knew that I saw a very serious traffic along Lagos Ibadan Expressway, and I was to enter. But because I saw that the traffic was thick, I decided to wait and was monitoring the traffic situation until I just saw all of a sudden that Google Map had turned green along that path. Everywhere was green. After a long time, I'm like, that would be a testimonial. The traffic, how did the traffic just disappear all of a sudden? Only for me to enter. And now realize that it was a standstill. Google Map could not detect any car movement. I felt that maybe all the cars that are on that road, maybe they were parked and it seemed the road was free, and just decided to change the traffic report to free road and just told me from Lagos to Ibadan would take me 1 hour, 15 minutes. Lo and behold, it wasn't so. So those are some of the things, but these are scenarios the system learns over time. But if we try to say that somebody will write a program to detect all these scenarios, no, it will be a tough one. And a very interesting one is identification, image recognition. When you can't program all the variances or all the options that could exist, scenarios that could come up for an image. If somebody wants to recognize me now, and you give the person my face, the frontal part of my face, if the system recognizes and registers me as such, and you program it as such, if I turn my side, the system will not recognize. So you have to write another code for that, and you have to do it for all the people. So the way machine learning has been designed so that it will be able to train itself over time. And that is why the rate at which technology is advancing, things are changing, voice recognition, image recognition, generative AI, system can compose and do all sorts. A lot of things are being automated. Data is going gaga. Before we used to talk about normalization and those things. No, it's gone beyond that level now. So, into business, I would like to, I'm sorry for, I'm still trying to call up some things on my system, and I found that. So, machine learning. I've tried to explain classification. I've tried to explain clustering. I've tried to explain linear regression. Those are the main classification and linear regression. Those ones are the one under supervised learning. Then trying to talk about the other ones, other unsupervised, then reinforcement and other ones. Now, I would like to say something about our data when we want to feed it in, issues we may have. Permit me to let us know, prepare our mind. You have to do some mathematics and some statistics here. So let us prepare our mind. So our data, there are some issues we used to have with data, and they call it data cleaning. We do that one all along. For you to work with any data, you have to do data cleaning. And the earlier, in fact, they used to tell us that you spend like 80% of the time doing your data cleaning and the remaining 20% doing the real work. So the process for managing this data cleaning, I would like to take some time to take us through the processes of data cleaning and the likes. The process of managing data, it is best to avoid data errors from inception than for us to have the problem of having to be cleaning data every now and then. How do we go about it? There are, so to prevent it, when you want people to enter their name into the system or enter their data into the system, you try as much as possible to make them do it right the first time, and you keep the record of that very first time. So when they are trying to report multiple records over and over, example, you go to work every day, you log in the time you enter. Imagine that there is a place where you are supposed to write your name or type your name, type the time you come in. If today, Chinoye, example, Chinoye types Chinoye today and her name and type the time. Tomorrow, Chinoye types the same name correctly. The third day, she now types her name and omitted the I, and type the time. When you are collating the data at the end of a particular period and you want to look at the trend analysis, or you want to look at data specifically meant for Chinoye, the system will recognize Chinoye differently from that person that where she omitted that I. And if you have an instance like that, it could be a very serious issue for us. I had data reports. I was collecting some data for my team for appraisals and trying to do some kind of scorecard. And lo and behold, some people changed their names at a point in time, got married and changed the name. Another person was using 3 names at a time, and towards another time, the person decided to remove the 3rd name. You can imagine if you have an email address and your email address is Chinoye Ronke Michael. You understand that kind of thing? So the person decided to remove the middle name so the email could be. And when I was collating my data, I was seeing these people. It was a large database I was working on for people that cross across regions. So I wasn't able to be fishing out to know precisely who is who and who is not. But some things are inconsistent. So person was there from January to June, and from June to July to September, the person was not there. Another person was here. So what could have happened? So that is where data normalization comes in. Just a little shedding of light on data normalization. When you go to some places, when you download data, there are some ways you put in, you type you can have a database where you have name, age, gender, department, and the only information they need is your time, the time you resume on a daily basis. But they are asking for name, age, date of birth, department, what again? Your employment number, gender, and you fill all those things every day. So that means every day you have like 5 columns that you repeat every day, which is actually a redundant process. So in data analysis, they do something they call normalizing. You don't need to have all those information. They keep all these extra record. They keep it in a place somewhere. You have your name, your employment number, your date of your gender, your department. They put it in a separate data. So if you only put your employment number and you put the time you resume, that is sufficient. Just like when we're in university, you only need your matric number. And when they plug it into a database, the database can now go to the backend and match it, just like VLOOKUP will do. We'll go and match it with maybe the biodata record or the master record somewhere, and then be able to know that, okay, it is this person that is this employment number or this matric number refers to. And that is how we work it out. So, unfortunately, my PowerPoint is not coming up. And I want us to do some demo on some of these things I'm talking about. PowerPoint is not coming up. Yes, so I have to change to another system, but I don't want to interrupt the class. So I'm just trying to see if I could take on this class up and the way I've been doing it, if I won't get stuck at a point in time. I once more apologize for this. So back to what I was saying, that is data normalization. So the same way when we are dealing with, the same way when we are dealing with database. Okay, so I think I have some things I have written down here. I said that we are going to talk of type of machine learning, supervised, unsupervised, reinforcement learning, then key terminologies. We're going to talk about features, labels, predictions, training data, then mathematics and statistics fundamentals. Oh, yeah, statistics, and then we're going to talk about probability and some things, then regression. Okay, yes, under supervised learning, I mentioned regression, and under regression, we have simple linear regression. I mentioned multiple linear regression, and then we'll have another one, polynomial regression. Okay, that one is maybe simple or straightforward. And say straightforward. Multiple linear regression is when you have multiple parameters, where you have things like independent variables, multiple independent variables, where you have maybe gender is as a factor contributing to the performance in the exam, when you have age contributing, when you have the type of school the person came from, and things and on like that. Then when you have polynomial regression, for some of us who did polynomial in school, polynomial simply means when you have ax plus bx squared plus cx cubed plus dx raised to power 4 and the likes. So that is polynomial. Then we have classification. I mentioned that one earlier. And then that is just giving you a Boolean output. That is the result. Your Y is going to be a yes or no. It is not going to be okay, like regression, when you have a set of data that will now say this person will get 50%, this person will get 80% of this one. No. That is classification. Then clustering. Clustering does not have any specific clustering is under unsupervised. Remember, I said it earlier. Under supervised learning, we also have some other algorithm. I would like us to know that one. Maybe I will share all these things on WhatsApp so we could see. Okay, I'll put it on the chat. I'll put it on the chat here. So we'll see. I just typed a question on ChatGPT. I say, please give me what question did I ask it to give me? A detailed guide or topics to cover under machine learning. So that is how it gave me all these things. So I just wanted to use it as a guide for the class. So under regression, let me even paste it for us to see now. Let me paste for us to see. Introduction to machine learning. So it will be as if this guy is just telling us stories. I think what I'm trying to paste is too much. Okay. Let me algebra means okay. And very interesting. We'll all be on the same page as I'm taking us one by one. All right, good. Yep. I need my PowerPoint to come up. God knows why. Why offended. So, talking about the algorithm, these are libraries that have already been put in place, or should I call them library or models that are already in place? You just call them up and you use these things to. So we have under simple linear regression, we have logistic regression, you have k-nearest neighbors, decision trees, and random forest. Note that one is a very popular one, decision trees and random forest. We have super vector machines, SVM, then naive Bayes classifier, as the name described, is a classifier, and it works a lot with probability. Then we are coming to supervised learning. We talk about clustering, k-means clustering, hierarchical clustering, DP scan, and on like that. Then under clustering, I would like to call our attention to principal component analysis, PCA. It is very interesting. Then dimension. Okay, principal component analysis is under dimensionality reduction. When you say dimensionality reduction, how do I describe that one now? If I don't have this thing to show. So yeah, dimensionality reduction. Dimensionality reduction simply refers to when you have several variables, independent variables, working to go several independent variables on in your data sets, and you want to simplify it. Just like, let me explain what it does. Dimensionality reduction. We talked about parameters or variables that could influence the age and that could influence the performance of a person in school, in an exam. You have age, gender, you have the time the person commits to reading, and possibly the background of the person, the school the person went to. Now, that dimensionality reduction works by compressing this information. It combines all those data. Like instead for you to have X1, X2, X3, it combines it in a code, encodes it in such a way that you can just have something, just a parameter. It will simplify it as if it's creating another Y inside your another X, a bigger X or a different variable that has all those factors embedded into it. That's what they call dimensionality reduction. So it will be possible for you to have as many independent variables that will fit into the outcome of your result, and you will be able to simplify. You can even draw a chart. Maybe you've seen instances where people are drawing charts and the chart becomes so cumbersome, it is not clear. Somebody will just draw your person wants to describe or put all those parameters into a single chart, and it will make sense. It will become cumbersome. So that is what dimensionality reduction does. It will be able to isolate the important ones, attach a weight to it, and give you the result that matter. And you'll be able to, just at a glance, you'll be okay with what we are doing. Now, I would also like to say something. I was talking about our data handling, data cleaning. I don't know, where is it mentioned in this place? Data cleaning. Yes, it is passed towards some part of it, towards the end, introduction and architecture applications to, okay. It talks about data cleaning, feature scaling, and handling missing data. It is a very practical aspect of machine learning, and it will make a mess of your work. You know everything machine, you know all the algorithms, but if your data is not okay, you might have some issues. An example of such an issue is something they call outlier. Outlier, an issue of skewness. Are we together? An issue of having fat tail or a thin tail, or some things that are difficult to or when you have the mean median mode of are not aligning. That means your distribution is not normal, abnormal distribution. Those things are the things you. So how do you determine outliers? What is an outlier per se? And when does a particular data point becomes an outlier? Can somebody give us a clue to that? Does somebody have an experience in that area?
An outlier is whereby a particular data is off the normal trend. Let's say, let me say, for example, your numbers are between 1 to 10, and a particular number is like 27. 27 in this range, that is an outlier.
So, is there any mathematical approach for that you are aware of?
No, I can't remember. Normally, when you plot them in like a bell curve, normally the outlier will be outside the curve. That's the only thing I know for outliers.
Okay. When you plot them outside in the bell curve.
Yeah, the normal range of values will be within the bell curve, will fall within the bell curve, but the outlier will be outside the curve. Yeah.
I don't agree with that. Bell curve is what you use to measure the distribution of your data set. Okay, so that means you are talking about it may be beyond the variance or under your bell curve, you
Yes,
have
beyond the
within
mean.
plus or minus, you have
Yes.
mean, you have standard deviation 1,
Yeah.
beyond
Yeah.
2 and 3. And
Yeah.
under, I think the third one is about 97 or 99% of the data set, supposed to be 90 something of the data set for a normal data set. Hi. I think I lost my PowerPoint, all the work I did yesterday. Okay, no problem. I think I'll actually make do it. I'm so sorry for all this one. I don't intend to waste our time. Maybe I'll have to do a quick rounding off. Or what am I saying? Okay, yes, I have it. Good. I recovered it. I recovered some things. Okay, good. Let me share my screen. Let me share my screen. Just unfortunate. Where's my screen?
Yeah.
Okay, yeah. Talking about machine learning, we pass through all the space. I've told you earlier that it has to do with more of mathematics than and I've actually tried to explain these are the things I depended on. So I won't run short of words. But thank God it is not what I have in the book. I have some things in my head. So then we talked about these categories: supervised, unsupervised, reinforcement. This reinforcement is what some people, well, should I say some that some people call semi-supervised, or like in between supervised and unsupervised. Then we have applications of machine learning. We talked about that one. In the financial, I was going through a particular data recently that's talking about the jobs that will lose to AI more. And I work in the financial industry, and I was not happy to see that the financial industry is going to be hit most by machine learning. A lot of things are being automated, all these credit card fraud detection, all those credit ratio, all these analysis they do for credit reporting. No, not credit reporting, credit rating for people. That one has been operational abroad for a long time. Then in the social media world, we know about ads. Ads. Once you click on, you want to buy a phone, they will advertise headphone for you. They will advertise earpiece. They will advertise pouch. They will advertise different things. Once you buy a laptop, they will advertise keyboard. They will all that thing related thing. Even if you buy just a book, other related books like workbook, something else by the author or related topics will definitely be advertised to you. And in medicine too, right now, the way robotics is going on, it has been trained to be able to do a lot of things. Of course, we are aware of all these robots, these humanoids. And I want to even say something. I'm thinking about it, and I don't know how we will feel. At this level, it seems as if machines will displace some of us. But come to think of it, if you are given the option to embed something into your brain, permit me, or to upload some things into your brain, such that apart from the fact that you have your human intelligence, you also be able to have access to information just like computer systems, all these machine learning stuff are doing. Would you mind? That's a question. Hello?
Hello, we can hear you.
Can you hear me? Yes, now it's something to think about now. At this rate, will you mind, even as a teacher, a
We mind.
robot, you will mind
Yes, that's an external body.
external body?
Yeah,
It's as if you are cramming something. It's as if they just put a flash drive, just plug it into your head. Or
is that not why we have
download.
ChatGPT? We can have it not necessarily inbuilt in our brain or part of our brain or part of our body. It can as well, just like ChatGPT is. We can always have access to all those information one way or the other. But putting that thing in my body or having a part of my body, I think I mind a little.
Okay. I don't know if anybody has any. I agree with your point. Anybody having the contrary opinion? If you have the same opinion, no problem. But if you have something to counter it, let's throw it up. Let's look at it.
I think I have a contrary opinion.
Thank you very much.
I think that I would not mind, to be honest. I mean, it's there is ease of understanding things and likes. I mean, it might not take as long to get to know something as it would normally without it and the likes. And I mean, knowledge is transferred faster and, should I say, simpler and easier. And yeah, I think I wouldn't mind. And even someone of a, I think it's even also it's not age restrictive as well. So you might even have someone that is even younger getting to know like more advanced stuff. I know, not that it's not happening though, but I don't think I would mind though.
Thank you very much. I appreciate that. So, what is the majority going for? What do we, can we just say, if you mind, just say mind. If you don't mind, just say you don't mind. Just can chat it if you don't want to say it. What do we think?
Mind.
Mind, okay. One.
I've already said I mind. So 2.
2, okay. Again. One person doesn't mind before. Is the person still
Yeah, I still stand on the fact that I don't mind.
okay?
And actually hope I addressed the question the way it was asked. So, but I don't think I mind.
Okay, so we have 2 people who mind and 1 person doesn't mind. Well, I respect individuals' opinion, so it is okay. I feel that we may need some extra information to be able to stay ahead of what is coming upon us in the nearest future. After all, some people or a lot of people go for spiritual reinforcement. So if this is an informational reinforcement, well, that is just me. That is just me. So, roadmap for machine learning, I talked about defining the problem, preparing the data, evaluating the algorithm, then improving the result. Then we present the results. Defining the problem, knowing what the problem is, what category of problem are we trying to resolve? Is it regression? Is it classification? Is it clustering or whatsoever? There are different ways and different problem categories. Then the data preparation, okay, like define the problem in coming down to real business case. We are in business school, we are in we might be consultants to anything. We are looking at what people will do. So if you want to know which people are going to buy, I told you before, classification is either a yes or no. people will buy or they are not going to buy. Abi, if you know how much the people are going to spend, you understand? You can have a data that talks about this category of people, maybe people of so age bracket and age to age bracket, you group it like that. So how much can they afford to spend? Or people at so and so level in your office, how much do you think they can spend? When these guys, Google ad, all those adverts they do, they have a way of targeting, and they have a, so they won't waste, because all this advert, it is expensive. When you say pay per click or pay per anybody that sees it, at times, by the time, a lot of people will just see your advert and waka pass, nothing. Look at all the advert that pops up at us when we are watching YouTube. How many of you respond to those adverts? So what they try to do, they try to be specific, except for one Christian movie I was watching sometime, and I saw the advert of these people selling gear, and I'm like, we need to work or we need not to work. I think something went wrong at that point. That should not be having attached to that kind of movie. I said they want to cause confusion to the people who are watching that movie. Do you get my point? That is what you are supposed to catch and detect when you are deploying your tools. I was asked to do a particular work in my office recently, and that was to people work in my office. We have a system that monitors how long people stay on the system and things like that. And people work in my office for average of 11, 12, 13 hours per day in a particular, and that is specific, particular department. And I was asked to explain. When you present some reports to management, that's why data analysis comes in. You present the graph, beautiful, it will tell you, okay, so what does this mean? And you are proud, you are saying, okay, these people, it seems as if social department spends so much time at work, and there's something, it's not reflecting in the volume of work they are doing. So they will now come back to you. So what is the problem? That is when you have to drill down to go and look at all the variables that are not seemingly reflecting in your report before. At times, you may have to combine some variables and say, okay, it is because this person is a nursing mother, and because this person is also just joined, okay, and because this person also just joined, that is the reason. You just need to bring out that information. And the beauty of data is that it is objective. It's not that somebody will be like, maybe they will sack me if they know the truth. I don't want them to know that I just had a baby, or I don't want them to know that I live in Ajangbadi, or I live so far away. That kind of thing. So, what with the data to be able to pitch it out? And let me tell you the outcome of my investigation. A lot of people in my office, because they have remote access to the system, they might just, first of all, just log in from home before setting out, like 6 a.m. Log in, check if there's any issue, there's no urgent issue, or quickly do some things after they have resolved anything that could be an issue. They head off to work. They may get to the office maybe 8:39. Work continues. Some of them will close as early as 4 o'clock. They want to beat the traffic. They will get home and go and log in again. They might even get home, relax, cook, do other things, enjoy themselves, and then come back to work. My friend, how do you explain that these people are not working 12, 13 hours a day? Do you get my point? So that is why, as an analyst, you need to go beyond just seeing the figures. You need to be able to understand, and you need to deploy the tools of all these things we're talking about. So if we are looking for people not behaving like, okay, if you want to create a group or segment of population, then that's a clustering problem. Then if you're looking for people not behaving like 95% of the others, then you're looking for outliers. I mentioned that thing. So 95% brackets is actually what is regarded as outliers. So inside your distribution, people beyond 3 SD to your right and 3 SD to your left, those are the people referred to as outliers. So when you are talking about preparing data in the real world is dirty. We have incomplete data, inconsistent data. Some people, their age and birthday may not be in the right form. I work with a data sometimes when some people across different countries actually submitted, and some people gave me day, month, and year. Other people gave me month, day, and year. Hey, I suffer that data. I suffer when you have to do the analysis, trend analysis time with time. So some data may be noisy when you have a situation whereby the salary, you are supposed to talk about somebody's salary and you see a negative figure is there. That is an error. Or when you talk about the family information and it is unknown, at times inaccurate data, you may have wrong formula. Copying a formula from one side to another could be a problem. Then we would have inappropriate data type. Now, let me explain something. There's something called coding and encoding of data. If you have done something on SPSS, you have heard about it before. When you are doing data, all these BX, B1, X1, if you have a situation like gender, and I know when we are doing exploratory data analysis, Dr. Francis did some things like that for us. If you have male and female, the system will not be able to put male and female into an equation. Are we together? Rather, you have to code maybe male is 1, female is 0. That is it. If you have situations where you are talking about a data spread across, let's say you are working with MTN and you want to talk about use of data or use of voice across all the 36 states in the federal, in the country, and you have to put it aside some other independent variables, like how much is being spent on the average per user, how long the time factor, you put all those things together. And lo and behold, you don't want to talk about 36 states. You are not talking about Lagos, Abuja. The system will not recognize it. So you have to encode it. You attach a code, 1, 2, 3, 4, different. So you put it. Then when you have translated your data, when the system comes up with some results, then you can now go back and decode that this thing is actually pointing to so states. Now, handling data issues, which I think I really want to take good care of this topic. That is deleting the observation if you have plenty. There are some, I am very careful with deleting observation. Maybe you can pull it out, put it in one side, and try to see the impact of removing it from the original data. You can pull it aside and see if it's not having any impact. Because if you have to delete observation, and it's also important that it depends on the size of those data that are giving you issues. If you have 100 data points and 25 of it is having issues and you have to delete, how do you go about that? Will you be able to delete? Maybe some people put their names, they don't put their surname in a particular data set. And because of that, you feel like, well, this data is not complete. You have to delete it. Or they omitted their date of birth, or they put their birth day and month, they remove their year. Some people try to hide their age for whatever reason and decide to hide it. What will you do? We are together in this thing. promise us I will close in the next 2 minutes. I want to round up in the next 15 minutes. Even if I won't run any data set. I have a data set I want us to run. But I want. Hello?
Yeah, we're here. Can hear you.
Yeah. What do you suggest? I have a data set and some people decided to omit their year of birth. Would it be okay for me to delete it?
From your notes, from what I'm reading from the notes, you said
Oh, you are reading my notes.
yeah, I've read to number 5.
Oh, okay.
To treat some data, to treat them separately. Yeah.
Okay, good. Okay, since we have already notes, I think we are good. We can jump to the next slide, but I'd like to ask a question. Do you understand what number 4 means?
No.
Okay, it is actually explain, transform the numerical variable into a categorical variable with extreme value in one bin. If you have the age category of people, and you see that in the class, in the LBS class, the age range is between 25 and 40. And surprisingly, you happen to have one 60-year-old person in your class. It will look like how will you describe it? It will look like that person is on the extreme end. You understand?
Yeah.
At the extreme end. So what will you do is that you group them. Binning simply means that you put into bins 0 to 10, 10 to 20, 20. Otherwise, your data may look somehow. The system may have to recognize a wide space with empty data before it gets to that person with 65. Are we together? If you group it into,
yes,
if you put it into groups of tens, that means between 10 and 70, you have 6 groups, 6 bins. If you group it into a group of 20s, you have just 3, and it will make life easy for you. So that is one of the ways of handling some outlier issue with outliers. Now, there's something they call concept of overfitting. The best thing, when we talk about fit, it means the system is able to predict your data perfectly. And that is the desire of any data analyst or any machine learning person. You want the model you prepare to be able to predict accurately. If I type Google now and say from here to LBS, it should tell me precisely. And if I get to LBS, if it's the time it tells me that I'll get to LBS, should be within a range of plus or minus 2 minutes. You understand? That is the perfect situation. But it may not always be. If it is that perfect, hey, then it would have factored in a lot of things. And if it factored in a lot of things along the route from my house to LBS, if I'm talking about the route from my house to, let's say, which village do I know close by? Let me say Songo, Ewekoro, passing through Songo, that it should predict where the road is very bad. The system may not be able to perfectly, work on that particular environment or that particular route. So we have to be very careful with overfitting. If you look at these charts now, we can see the chart 1, it looks like it didn't recognize, it used a straight line to do a line of regression, which should have been a non-linear, is it non-linear? Yes, non-straight line, yes, a non-linear graph. So this second one is actually tracing the best line of fit with very few outliers. Definitely there are outliers. But look at the third one. No. I mean, sorry. Did I say what did I call it? Did I call it outlier? No. They are call it data set not falling on the line, on the straight line, on the line of best fit. But this one, the line of best fit is catching almost everything. Who does that? So it is not a best because it will fit your training data, but when you now want to apply it to real life situation, you now start messing up. Just like situations where they talk about Google, is it driverless cars? We've tested it in some environments and they are working very well. And they tested it in some other environments, it could not perform. I believe that a driverless car that performs 90% accurately in the US, if they bring it to Nigeria, I believe you can guess what the answer will be. It will definitely, by the time you encounter some potholes, and he will now understand how to navigate between a pothole, between an Okada, thanks that they took Okada out of Lagos, but they are still in some places. Navigate between potholes, Okada, you will be able to know better. So that explains that. So this is what the graph below is trying to talk about, overfitting and not fitting. A straight line like this gives us what we require. This one below is actually a case of classification. Is it classification of clustering? Separating the red from the blue. It doesn't need to be perfect. So now feature scaling. When we talk about data sets, I mentioned something, normalization. Data normalization is slightly different from feature normalization under feature scaling, different from normalization under feature scaling. So data normalization, as I said, is when you isolate some data that are supposed to be redundant. You can go under ChatGPT or on your own, just type data normalization. I've mentioned this thing to us before. One time I took Excel. Just type data normalization, and we'll try to explain to you that data normalization is when you have a large set of data and you have to strip off some things so they won't be redundant. You won't be repeating them over and over and over. Now, feature scaling, when you are doing feature scaling in normalization here, it's a system whereby you try to, it's similar to standardization, but they call it normalization. Now, listen, it will arrange your data, it will convert your data to a variable that is between 0 and 1. It will convert your data into a variable that is between 0 and 1. In our class, for example, we have people of ages 25, 30, 35, 40. Again, 25, 30, 35, 40. So how do we normalize this one? If you are putting this kind of parameter on the charts on the system will recognize, are you going to ask it to start from 0 for the ages, or just for this data set, you want it to only recognize age between 25 and 40? But how do you want to know which one is maximum, which one is close to the upper limit, which one is close to the lower limit? That is how this normalization comes in. So to normalize 25, for example, 25, you will say the range between the highest and the lowest is we say maximum minus minimum, which is 40 minus 25. That is 15. So every other thing you have will be between that 15. And you normalize it so that even the one that's supposed to be the highest will have a value of 1, and the person that have the lowest will have a value of 0. So if we want to normalize 25 now, you have 25 minus minimum, which is 25 minus 25. That is 0 all over the range, which is maximum minus minimum, which is 15. So 25, if you normalize it, the value of person of age 25 will be 0. Are we together? We get it? Do we get it?
Yes.
25.
Yes,
Okay, yeah. 25, and then when we normalize it, this person will have 0. Now, for the person with 35, what will be the normalized figure be? This thing I'm talking about, you will see it when you are doing running one of those algorithms. So what will 35 be?
Would it be 0.15? Because you said the maximum is 40, right? And the minimum is 25.
Yeah, exactly.
So 35 minus 25, which is 10. 10
Okay.
over 15. Yeah.
Okay.
Which
10
is like
over 15.
0.15. Yeah.
10 over 15?
Uh-huh.
0.6.
Okay, 10 divided by 15. Okay, 0.67. Yes, 0.67. Yeah.
Okay, 0.67. Now, what should 30 be? 30 should be 0.33, Abby. Abby? 0.33.
Yes.
33. Now, 40 will be what?
What will be not 0? Because 40 minus. Okay, no.
it will be 1.
40 will be 1.
1.
That is data normalization for you. So your data has been converted, it has been encoded into something else entirely. Not talking about the 25. So when you are doing some, that is why I was mentioning mathematics, statistics, emphasis. I mean it. Now, when it comes to standardization, it also follows a similar pattern, but instead for you to use minimum, you use x minus mean all over the variance. Is it variance? All over the standard, what do you call it? This is variance now. Am I right?
Okay. Yes, it's variance.
It's variance. It is when you square it, it becomes
Standard deviation.
Standard deviation, yeah. So it is x minus the mean. So we look at the mean of these 4 figures. What is the mean? 25, 35, 30, 40. What's the mean? That mean is what we subtract this one from. Then we'll find our variance and use it to divide it. And it will give us.
It's standard deviation. It's when we square it that it turns to variance.
It's when we square. Oh, yeah. Thank you. It's when we square it becomes variance. Thank you for, like one of my teachers will say, if he has made a mistake, he said, hey, I use that one to test you, to test that you are following me. So, yes, that's it. So, when you do it, and most likely your figures will be between the minimum standard, deviation and the maximum standard deviation. Do you get the point? And the good thing about this one is that you will get negative and you get positive. It should now be able to draw a bell curve or a normal distribution curve around your distribution. This one standardizes your data set. Are we together?
Yes, sir.
Okay, that is that about that. Now, This is the last slide. That is the last slide. Okay, some of my slide did not save. Okay, no problem. So that is all about that. Then the outlier stuff. There's something about outlier. I said earlier that it falls within 95% of your data set. That is between, I think it's third standard deviation and third standard deviation. Anything beyond that standard deviation is is an outlier. Another way for detecting your outlier is you use something. There's a formula where you use your interquartile range. You use the where you have this quartile, the first quartile and the fourth quartile. Then there is something about it. Once you are able to know what your maximum point is supposed to be and what your minimum point is, anything below those maximum data sets is outside of your it's an outlier. Then there is also another thing they use for outlier. This thing they call box plots. You know it? That thing that has a kind of is it a box and whisker, or what do you call it?
Yes, sir.
That box plot actually has some information, very sensitive information, if you look at it very well. It talks about the mean. There's a line, there's a box like figure 8. It has a line in the middle, which is the mean. It has a line above, it has a line below. Then that makes that 8. That is the data set describing, how do I describe it? I can't remember offhand right now. Now it now has something that looks like a T on top and below an inverted T, giving you some abstract information, explaining the points beyond which your data set should not go. Anything outside that upper point and the lower point is an outlier. So those are the few points of mine for. Let me run a data set. I'm trying to see if this thing will work now. Let me use Google Colab. I've already prepared a data set. Okay, I want to guess. You may not be able to see you are not seeing my screen now, are you?
Can see your screen, feature scaling and feature
okay,
scaling.
yes, no, I've moved on. I will have to change it. Let me move to here.
On share and start sharing again.
Yeah, I will share and share again. Okay. Where is the last one I did? Share again. Share again. Share my screen. Screen 2. Yes. Okay. I'm trying to show us something. Okay, these are some of the terminologies we come across. We know about this one, importing the library, import NumPy. We know this one, import pandas. This matplotlib, yes. Then data, importing the data set. I need to import the data set and make it consistent to read from my CSV. So let me bring my CSV file. Bring my CSV file. Okay, this one has been run. Okay, you running? Okay, yes, it's run. So we understand of importing data sets clearly. Then data set is equal to, if you want to do it in Anaconda, you just copy this social network at CSV, just copy it inside the same directory where you are running the file. So let me run this one. Let me import the data sets. Good. Now, one thing you will do, the data set has been run. Let me check it. X. Enter. Why? Has been run now. Oh, sorry, didn't run now. Name input error. Why? Okay. Do you know what the issue is? This data set X. Now, this data set we are looking at, let me show you the raw file, what it looks like. It is actually a social network hard. Okay, maybe I should give you this data file so we can also run it on our Anaconda. Or if you want to run it on Google Colab, just the way I am. So I'm opening this data set so we can just see by ourselves and then play around it in Excel. This is it. I don't want to tamper with that raw original file. Save as. Save as. Okay, can you see? It has a data, it is a data of about 400 people, different ages, estimated salary, and now the outcome, this is parameter A, this is parameter B, and that is variable B, and this is now the output. The person bought or did not buy. Remember I mentioned when you are doing adverts to different people on the system, there are some adverts you don't target at women. There are some adverts you don't target at men. You don't need to bother. Like if somebody comes and start telling me to buy pepper, there's somebody who came to advertise bell pepper to me. Pepper, I should buy pepper. The pepper is good. It's very beautiful, sincerely speaking. And I bought. But when I got home, and my wife said, this is too expensive. This is how much they sell it in social place. This is how much they sell it in that social place. My parent, you think I will buy yellow, green, orange pepper again. So targeting that advert at a man may not be the best. Now look at it, 0 in this case is supposed to be buy or not buy. But this thing has been encoded. Purchase, when it's 0, means the person did not purchase. You understand? How together?
Yeah.
And when the person bought, it is seen as 1. You get the point? So now, if you now want to draw a chart, you can do a pivot, you can do something whatsoever on this one to look at. But what we are looking at is a graphical presentation. If I want to do a pivot on this thing now, insert, will pivot work on CSV folder? It should. Just put it on this sheet. Put it here for me. Yeah. Now, what do I want? Purchase or no purchase? Age. How many people? Then I now put estimated salary. Yeah. How do I put this estimated salary? Looking at the age. If I put estimated salary, that will now be an additional second layer, and this thing may not describe it appropriately. So you can see now the age range of people who bought are people from age 27 and above. Can you see? Are we together?
Yes.
Yeah, now you can unmute now. I'm more comfortable. There's no noise coming from your end. Let's also be together. Looking at this data very well, the people who bought are from age 27 and above. The people who did not buy, most of them, they didn't even buy at all. But the people who did not buy, some of them happens to be between this. And if you can see, there is a kind of decline. The people who did not buy, from this point, it is declining as they are growing old. And from here, it is picking up. So how can you describe what this kind of product could be? Maybe it might be a car, or that is just one. Now, the second aspect of it, let us look at the salary and see what it will give us. Use the salary to do another review now. I remove age. I put estimated salary here. Oh, good. People who earn below 19,000, they don't buy. People who earn above 20,000 are the ones buying. And people who earn beyond a certain level, they stop buying that product. I don't know what that. No. People between this point, a certain stop buying. Then from a particular range again, they started buying. So can you see the pattern? How do we describe it? It is possible that some of them are just happen to be outlier, that their category, they don't usually buy that type of product. So going back to our analysis, we come here, you see what our X data is. What do you think is our X data? What is this one? What is the X data? The age and the salary. So what is our Y data? Our Y data is the outcome. That is Y is a function of 2 X variables. Are we together? Or should I be typing? Should I start typing? Should I start typing all these things so we'll be able to be on the same page? I can do it for you. I'm using 2 screens. I'll just put this on one side. I'll quickly open Anaconda and we'll be able to, where is this thing? We'll be calling it up one after the other. Where is this? Except that we are running out of Time. Let me finish this one. I will send the file, this Python file to us. Now, I've shown us what Y is now. So what X is? Y is the outcome. That Y, what you will see there will be zeros and ones. Is that okay? Want me to demonstrate?
Okay.
Yeah, it will be zeros and ones. Let me show it here. This is X and Y. No, small y. Let's run it. Can you see? Zeros and ones. Now, when you are working in machine learning, there's something they call model sklearn. It is a library. So from sklearn, you import train test splits. It is, you don't need to worry yourself too much. What you are trying to do is that you are trying to say, this data set I have, 400 data set, I want you to pick part of it to test my analysis, then use the remaining one, to train my data, to train my model, then use the remaining one to test it. How? It will pick out of 400, it will pick, they usually use like 80% to train and 20% to test, or some people use 70-30, some people use 75-25, whichever. So, but that is the system. So they use a large data set and the system will automatically randomly select that portion you want to use it to train. It will select it, use it to train. After then, it will you now ask it to test that model on the other one. Now, when it is testing on the other one, it will now generate an independent Y. It will generate its own Y, which is the regression. After it generates the Y, it will now compare that Y it generated with the original Y on that data set that it is using to test. All together? Maybe I should take it again, or I should calm down, calming down small. Are we together?
Yes, we are with you, sir.
We are, okay, good. So it will use sklearn. Sklearn is what they used to do. Apart from sklearn, which other model do they use? There are different ways, different approaches to this, different libraries. For example, if you go to ChatGPT, you can just say libraries for training or testing or splitting data set into training set and test sets. You can just type it and might give you more than this option. Sorry, permit me to let you, Abi, permit me to be vulnerable, to give you my secret. Whenever I get stuck, I go to ChatGPT. And as a matter of before ChatGPT, they use this thing. What's the name of that website we used to go to? Can't remember. There's a place where we used to go to. Once you type in your problem, somebody would have had that problem. It is like a tradition. When you are learning programming or when you are learning data, you must learn how to use that. What is it? So you just go there, type your problem. Even if you encounter an error in Python, just copy, go and paste it there, and it will bring out something for you. So this is the pattern. This is it. You do X train, comma X tests. The way this thing is generated, upload this data set. From this data set, it tried to fish out the X and the data set, which are the dependent variable. Then it tried to isolate the one that are dependent variables. We understand this one. iLog, we used it before with Dr. Francis. So now this one will give you X train, X test, Y train, Y test is equal to, it will give you 4 different parameters, just this single line, 4 different data sets. Then you now have train test splits X, Y, test size. I mentioned this one before. test size is 0.25. That means what is going to leave for the test is going to be 25% of the data set. That means for the training, it will select 75% of the data. Automatically, it will do that. Is that okay? If I run this one, we'll see what it will give me from what we've been working on all along. Yes. Run. Then, let me ask it to give me the extreme. It did the selection randomly by itself. Out of 400, that means the extreme, this should be 40, this should be 300. You get? Then this one will be Y train. That will be also be 300. Now X test is going to be 100, and this one is also going to be 100. Now, pre-processing, import standard scalar. We are going into what I mentioned earlier. Let's talk about normalization and standardization. This standard scalar will transform your data in a particular way. So this is how to use it. SC is equal to, you have imported standard scalar, S is equal to standard scalar, then import, or you could, instead for you to have something as SC is equal to standard scalar, this, you could have as SC. So you have S is equal to standard scalar, this, then you have X train, XSC dot fit transform X train. X test, the same thing. You transform it. You do a transformational process. Are we getting it? Should we look at our data again and see what our transform data is looking like? I told you that it is going to use standardization, and that is what it has done for us. Yeah. So you will see between 0 and 1. You will see the information between the minus 3 standard deviation and plus 3 standard deviation. That is the information you have. Mind you, we don't have any negative figure, so it has transformed it all the same. Now, training the logistic regression model on the training set. So we are using logistic regression. Remember, I mentioned linear regression before. So this one, we are using logistic regression because this one is not a linear regression. What type of algorithm is this? Let me ask us. Is it clustering, classifier, or regression? Are we together? Are we together? Are we together? Are we together, please?
Yes, sir.
Yes.
Which category? Which one is it? I asked you a question. I gave you options. What type of regression are we doing here? Okay. Okay, let me run the entire. I know I've taken our time, but I'll give you this data. There's also something they call confusion matrix. I didn't mention it in my stuff. It is when you do your analysis, you try to look at the variances between your Y prediction and your actual Y train. No, Y test, sorry. Your Y prediction and your Y. So you check the accuracy, and then you'll be able to know. There's something called confusion matrix. That is what you use to test the difference between the variances. And you use it to do something they call a mean square evaluation. The variances, you do to do some variances, you do something to check for R. R is talk about the accuracy or the efficiency of your regression. So that is what you use the confusion matrix for. Then from here, I told you use the logistic regression. That is what we are using here, logistic regression, to classify the data into either buy or don't buy. That is just what we want to do. Buy or don't buy. That's what we are doing. So you have the data here like this, and it's expected to transform your data. Now, when you get your results, it will give you the information. You check your confusion matrix. When you check your confusion matrix, you now be able to go back and test again. Maybe instead for you to be, you have used 25% as a test, you can decide to use 20, you can decide to use 30, or you can decide to change from logistic regression. When you are doing machine learning, it's maybe this type of data alone is what they will give you as exam. They may just say, okay, test different models and come up with the one that is the best. After you have done your standard scalar, you have done everything. If you don't do standard scalar, you might get something out of this, something else. So you use your confusion matrix to do the analysis. That is where you understand some things about false positive, false negative, when it is accuracy is high, when the adjusted R is okay or not. Then also, for this kind of classifier, visualization is the best way to bring out your results. Just like we were talked about plotting last week. You just use your matplotlib colors to check matplotlib, or Seaborn, you understand, to do the plotting. You have plots on X label, Y label, estimated salary, the same data set, what you have training, and you visualize everything. So let me run the entire data set for us. So we'll be on the same page, and we see. Sure, we can see this one. Standard scalar. You see what it gave us? Can you see something? Then it's changed, it transformed the data entirely. Then this one is the X test. It's also, so the two of them will be easy to compare. They are between the 3 standard deviation negative and 3 standard deviation positive. Now you have the result, the test result, and we want to visualize our data. Logistic regression training set. This is the 75% it used to do the training, and it will now test it. If you see the data points here are plenty, there are more, and the ones here are less. Now comparing it with our Excel, which we try to analyze about the age, the ages of from here, ages at what age did we say that these guys don't buy something? You know, we are, I think it was around 18 or so, was it not?
I think 19, Abi 7.
19. So
yeah,
it should be around here, Abi, because this is age. So it should be around here that these guys will have to start buying. Abi, if you target anybody from around, Abi, am I right? Where's the Excel file? Close it. This is age. Oh, sorry, 27. It is at age 27 that they start buying. Can you see? Hello?
Yes.
And at age 52, the people who are not buying, that was where they ended, except for this kind of outlier. So going back to our 27, and this is what we are talking about. Is this 27? Something like that. or like this. I think this is like 27. Can you
Yes.
see? And this is able to draw a line to say, and at 50 something, these guys that are not buying. So people from this place is exclusively people who buy. And look at the salary too. The salary. These guys, the people who don't have much money. People who don't have much money. Few of them, like what percentage of the entire length can you see? And the people who are buying increased towards this point compared with this entire length. Now, when you do the tests on the final results, see what we get. It was able to predict, to bring out its own, how do you put it? Its own test set, impose the model on it, and it just worked perfectly. You can see we have few number of this blue in this side, we have few of this. So what will determine if we got our information is perfect or not? It is the confusion matrix that will give us the answer. See the accuracy stuff, 89%. Now, if you say 89%, you don't just say 89%, there's a general category of what is expected of your accuracy store. Comparing Y test over Y predicted. It will compare what the normal thing and what the prediction is going to do. But when you are comparing, when you are using this accuracy store, you may say, okay, 89% is good. But when you are comparing with another algorithm, you may be able to say, okay, this one is better. This one predicts my model better when I tested it on the test data. At this junction, I'd like to ask if anybody has a question, and I would share this stuff with us, this social network at CSV. I will also share the Python code with us so we'll be able to play with it. I wish we could have been playing with it live and direct, but I think it is good. I laid all the facts on the ground here, so we are all able to be on the same page. Chinoye, I've eaten into your time. I hope it's a good place to stop and hand over to you. Are we still together?
Yes, we are together.
Yes.
Okay, Chinoye, is this okay? Yeah, are we at a good point to say we've been able to lay the foundation right on introduction to machine learning?
Yes, sir.
So I don't know how many algorithms we'll be able to run. I think Dr. Francis will be around to take care of those other algorithms, or maybe we'll still repeat another data set using this same process so we can have better understanding. By the time we reinforce it, it's what they call reinforcement learning. Reinforce it, we discuss it, we look at all this line by line in detail. We'll be able to say, hey, this is what this guy was talking about. But mind you, I'm telling you, I had the same experience. The first time this confusion matrix, when they started talking about it, was like Greek to me. When they are talking about all this, in fact, I was like, and unfortunately for me, I missed some classes before the machine learning class. So I was struggling to understand a lot of things. It's really threw me off. So I hope we're able to do just, we took our time to think, explain all this things. But well,
Thank you, sir.
thank you so much. See you some other time.
Thank you, sir.
So I will send that stuff, that data set,
Okay.
For us to run.
Okay.
Take good care.
Okay, sir. Thank you.